So hello guys, we are dealing with the second problem in the fluid mechanics series, and this is problem number 1.318. The problem is stating a wide vessel with a small hole in the bottom is filled with water and kerosene. Neglecting the viscosity, find the velocity of the water flow if the thickness of the water layer is equal to H1 equals 30 cm and that of kerosene layer H2 equals 20 cm. So this is the diagrammatic representation of the problem which we have drawn on the screen. So we have water which is of a more denser liquid having 1000 kg per meter cube. Kerosene which is immiscible with water is having density 800 kg per meter cube and hence floats on the surface of water, and a small hole is made over here at the bottom of the fluid. Now what we are going to do is we need to understand that we are going to apply Bernoulli's principle between point 1 and 2. Now when we apply Bernoulli's equation, we state it as, so we are writing applying Bernoulli's equation. So we can write P1 plus rho g H1 plus half rho V1 square equals P2 plus rho g H2 plus half rho V2 square. So over here the first thing that we need to understand is the value of P1. So 1 is a point which is inside this container and 2 is a point just outside this container, and 1 and 2 they are both are at the same horizontal level, and hence we have written H1 equals H2, that is rho g H1 and rho g H2 is same. Now if I write pressure at this point 1, then it is due to the liquid column of kerosene, liquid column of water and atmospheric pressure P0. So hence we can write that P1 can be written as P0 plus rho 1 g H1 plus rho 2 g H2. Rho g H1 and rho g H2 are same, plus now inside this liquid layer at the bottom point the velocity is 0. The moment the fluid comes out of the container, it is having atmospheric pressure P0 plus flow velocity half rho V square. So now outside the flow is due to water, so we are writing it as half rho 1 V square. So hence over here if we solve for velocity, then we can say P0 and P0 will cancel out and we get the expression as half rho 1 V square equals, if we cross multiply 2 and take g common, so we can write it as 2g rho 1 H1 plus rho 2 H2, and hence over here the velocity of flow can be written as 2g by rho 1. So we write it as H1 plus rho 2 by rho 1 H2 is square root. So this is the expression for velocity that we have, first part of the problem. Now the problem is asking us to calculate this value. So for calculation of this value, we put the values the way it is given to us. So 2g H1, so H1 is 30 centimeter plus rho 2 by rho 1, rho 2 is kerosene by water 1000 into H2. So H2 over here is 20 centimeter, 20 by 100 is square root. So this value is in meter, and on solving we obtain it as meter per second. So this value is in meter per second, and on solving we obtain V equals 3 meter per second. And this is the final part of this problem. So this is the second problem in this series, and it is problem number 1.318 which we solved.